For the Cartesian coordinate system, we have solved the Schrodinger wave equation in one-dimensional Cartesian coordinate, and also we have done two-dimensional and three-dimensional system in a Cartesian coordinate, which is nothing but the replica of one dimension. And again, you are doing for all three-dimensional independently, and you can solve this problem. So, but the system in physics are have different symmetry. They can have rotational symmetry. So when you are solving about the rotational symmetry, then the role of angular momentum will very predominant. So let us figure it out. What is angular momentum in quantum mechanics? And it is also known as space quantization. Why it is known as space quantization? And right now, up to this, we have seen that momentum quantization, energy quantization, this kind of thing we have seen in the one dimension. And now we will just try to figure it out. What is angular momentum? So for to understanding angular momentum, today we will just try to figure it out. What are the angular momentum operators? And next class we will just go for the angular momentum algebra. Algebra is very important, and this is the same logic that we have learned into this harmonic oscillator for raising operator and lowering operator. And but here we will learn the ladder operator actually. It is very popularly known as ladder operator. So let's start with the very basic, and we will discuss each and every point that how this spherical symmetry can be decoded by this angular momentum physics of quantum mechanics. So let's go for this. So what we have angular momentum as a vector, and this is classically r cross p. This is the well definition of angular momentum, and we have three component of angular momentum. The three component is lx, I, ly, j, and lz, k. I can define lx as ypz minus zpy, ly as zpx minus xpz, and lz as xpy minus ypx. So these three component you can easily figure it out with the form of r cross p. But we have to learn for the quantum mechanics, and up to this we have only one dimension, and even in two dimension and three dimension we are very much sure that x and y is going to commute, so there is not any problem to getting the simultaneous eigenvalue. Here we have three component lx, ly, lz. So is that these three component are good quantum operators? Or if you want to know about the L, the basically if I know Lx, Ly, Lz simultaneously, then it's over. But let's check whether Lx, Ly, and Lz can measure simultaneously or not. So let's go for the commutation algebra. So first we will go for the commutation of Lx and Ly. So if we will go for the commutation of Lx and Ly, so Lx is all about ypz minus zpy, and Ly is all about zpx minus xpz. We have to just see whether they are commuting or not. So what we have? We have four term ypz, zpx, and second term is this and this we have taken. Now this and this minus ypz, xpz. Third term is minus zpy, zpx, and the fourth term minus minus plus is Z Py X Pz. Now, which term is going to survive? Can anybody tell me? Which term is going to survive? Is that first term is going to survive? Say yes or no. Anybody?
No.
No. Why not?
Say
There
yes,
is a
yes. PZ.
chance. There is a
Yes,
chance you
sir.
can get Pz and Z. So it is going to survive. Second term, sorry, it is not going to survive. Third term, sorry, it is not going to survive. Fourth term, it is going to survive. So yes, first, so these two terms are 0, 100% 0. So which term is going to survive? Here Pz, Z, and you have Y, Px, plus this term is Z, Pz, you have Py and X. What is Pzz? Minus IH cut. So this is YPX plus ZPZ is IH cut. XPY. So this thing I can write XPY minus YPX with multiplication of IH cut, and this is nothing but LZ IH cut. So what we have get? We have get IH cut LZ. So similarly, you can also figure it out. Ly Lz is IH cut Lx. Lz Lx is IH cut Ly. So it is a good news or bad news?
Bad news.
Bad news. It is not only bad news, it is very bad news. Why?
Lx and Ly are not simultaneously measurable.
Very good. So if Lx, Ly, Lz are not going to simultaneously measurable, then how you can measure L? This is a very big task. So working angular momentum in a Cartesian coordinate is not a worth thing to do. So why we have to go in a different method to understand. Now, there are two ways to understand the vector. Either you will get the all three component, then it's okay. Or you can get the magnitude and direction, then also you can get the vector. It's a very trivial, very simple thing. Either you can get the magnitude and direction, then also you can define a vector. This problem doesn't arise into our one dimension or in Cartesian coordinate x, px or linear symmetry. But once we are going into the rotational symmetry, because angular momentum is all about discussing the rotational symmetry, you have learned into classical mechanics. So let's try to figure it out. What will happen to magnitude and the direction? So obviously, magnitude is nothing but mod L whole square root under. This is the this is the magnitude. L square root under. So root is the very tough thing to deal with this to in a term of operator. So what we have taken? We have taken the L square operator. And what is Lx square operator? Lx square, Ly square, Lz square. So let's try to figure it out. Is that L square and Lx and L square and Ly and L square and Lz is going to commute or not? So one will commute, then another will also commute. There is not any problem. So let's try to figure it out whether they are commuting or not. Magnitude and one direction. Lx, Ly, Lz will tell you about the one particular direction. So let's try to figure it out that they are going to commute or not. If you have any doubt, you can just raise the question.
Excuse me, sir.
Yes.
Sir, in commutation of Ly, Lz, the value is iota L h cut Lx या Ly?
Lx, Lx तो अरे एक बार लिख दिया तो आपको दिक्कत क्यों हो रही है? Lx, Ly, Lz, Ly, Lz, Lx ऐसा ही तो होगा. थोड़ा तो दिमाग लगाओ. नहीं याद करने का तरीका. Lx, Ly, LZ, LX LY मिला LZ, LY LZ मिलेगा LX, LZ LX मिलेगा LY. अब याद रहेगा? बोलो हाँ या ना.
Yes, sir.
हाँ.
Okay.
चलो LZ LX क्या होगा?
LY.
LY. LY LX क्या होगा?
LZ.
LY LX
minus
माइनस
minus
LZ.
IS cut.
माइनस IH कट LZ. उल्टा जा रहा है ना. चलो let's go for see the commutation of L square and LX and all other thing. So what we have LX square, sorry, L square as LX square plus LY square plus LZ square, and I just want to see what will happen L square and LX. एक को निकाल लेंगे तो बाकी अपने आप निकल जाएगा. So we have LX square plus LY square plus LZ square and LX. What we have LX square LX plus Ly square Lx plus Lz square Lx. This is 100% 0. This can be written as Lx Ly, sorry, this can be written as Ly Lx. एक बार Ly पहले लिखेंगे तो दूसरी बार Ly किधर लिखेंगे? बाद में लिखेंगे. याद है? ऐसा सिखाया था. That will be Ly after that. Similarly, you can write Lz Lx plus Lz Lx Ly. So whole story is there. What is Ly Lx? Minus, isn't it? Minus IH cut Ly Lz. Again, this one is again minus IH cut Lz Ly. Here is Lz Lx plus IH cut Lz Ly plus IH cut.
Last में LZ होगा.
Sorry, this is LZ, है ना? This is LZ. So this will be Ly Lz. What will happen? The thing is going to cancel out, isn't it? YZ. So this and this is cancel out. This and this is cancel out. So here you can have a very good news. So similarly, L square Lx is going to commute. L square Ly is going to commute. L square Lz is going to commute. So here you can have all three commutations, and we have very good news that at least I can have L square and all the direction can be measured simultaneously. So what we need magnitude and one direction. If you need magnitude and one direction, you can tell about the vector. It's a very simple. So I can take either L square Lx or L square Ly or L square Lz. These two things we can take. Now I am doing this thing in another way. So if you are talking about a spherical symmetry and keep the radius fixed, I am not going for the radius. R is not going to change. This is theta and phi is going to change because we are talking about the rotational symmetry. So theta is going to change and phi is going to change. So if I am fixing the R, how many degree of freedom is there? 2 degree of freedom. One is for the theta, another is for the phi. So here also, to define the angular momentum, because to defining the angular momentum, the radial part is nothing to do with the angular momentum. What is going to do is the changing of theta and changing of phi. So how many quantum number you need to define the angular momentum?
2.
2. आज दिन में ही तो सीखा था, जितनी डिग्री ऑफ फ्रीडम होगी उतनी ही क्वांटम नंबर आपको चाहिए होगा. सो वी नीड 2 क्वांटम नंबर टू डिफाइन द सिस्टम, and let us figure it out how we can get 2 quantum number. So obviously these 2 quantum number have to associated with 2 different operators. So which one is the 2 different operators? One operator is 100% L square. And what should be the another operators? It may be Lx, it may be Ly, it may be Lz. But for the convenience, I am using a very lenient word that for the convenient, we are using Lz is my favorable operator. Why I have chosen this convenience, I will deal it after 5 minutes. Okay, you will give me the answer why we are choosing this convenient. Okay, so what we will do, we will just figure it out what will be the common eigenfunction for the L square and Lz. This is our main thing. Obviously you can also figure it out the common eigenfunction for L square and Lx, because they are also commuting. You can also figure it out the common eigenfunction for L square and Ly, because they are commuting. But for the biasing nature, for the convenience, I am going to take L square and Lz. You will also give me hint why I am taking this. So wait a minute. So let's go for up to that. If you have any doubt, you can just raise the question. You can ask question, don't worry. You can interact, okay? Not unnecessary, but you can interact. Okay. So let's go for. So what we will do, we will just write each and everything in term of theta and phi. So okay. So I am writing Lx, Ly, Lz in theta and phi. You can just take x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, z is equal to r cos theta. You remember all this thing. You can easily find p, what will happen to px, py, pz, and you can write this thing. Don't go into this derivation. Just remember all this thing. So this is all about Lx is equal to I h cat, and this will be sine phi del upon del theta and plus cos phi cot theta del upon del theta. I think I am correct. Similarly, Ly is equal to, this will all about I h cat, and you can write minus cos phi del upon del theta plus sine, sorry, this will be sine phi cos phi, there is sine phi cot theta del upon del theta. Please check it, this is cos phi. And what will be Lz? Minus I h cat del upon del phi. Now please tell me, if you have same purpose from Lx, Ly and Lz, which operator will you choose?
LZ.
100%, because we are human, isn't it? We know that where our life is simple. If you are going to solve this thing, you have 2 variables. Sorry, Just a minute. Just a minute. Sorry, this will be phi. This will be phi. This will be phi. Just check it. Just check it. This is phi. This is theta. This is phi. Just change this. So obviously, these two is very lengthy. If it will also because L square and Lx is also going to commute, L square and Ly is also going to commute, and L square and Lz is also going to commute. And solving this Lz is very simple for us. Why we will go unnecessary into this thing? Okay, this is one of the logic from my side. This is not the actual logic. What is actual logic? Actually, the evolution of angular momentum algebra is to understand the electron in a orbit with a coupling of magnetic field. So what will happen when electron is moving in xy plane? The electron is moving in xy plane and electron have charge. So where is the magnetic moment? And that magnetic moment is in perpendicular to that xy plane. Are you agreed?
Yes, sir.
So magnetic moment is in xy is perpendicular to plane, and that is in the z direction. So why we are much more favorable towards Lz. This is the physics. So what is your Lz? How you determine this is my Lz? Just defining where is the magnetic moment of the electron. And once you have find that, okay, this is the direction of magnetic moment, this is your Lz. And this is not just a fixed Lz that you can say only this is Lz. You have your own choice that you can say, okay, this is my Lz. So how you will define that this is your Lz? You can define this thing by figure it out what is the direction of magnetic moment, and that is the direction of Lz. So why we are so much biased towards Lz and L square. But yes, I love mathematics. So due to mathematical reason, I will also go for Lz. Okay, so let's go for figure it out what is the eigenvalue and eigenvector of Lz. Then we will also calculate what will be the eigenvalue and eigenvector of L square, and then we will form a new function, a new kit. And first time you will find that we have a kit which has two quantum number. We have also get it into two-dimensional box and three-dimensional box, but here it's a very interesting. So let's try to figure it out. So Lz is minus I h cut del upon del phi. Let us assume this is capital phi. So this is function of a phi is the eigenfunction. And mu is the eigenvalue. And this is just azimuthal angle, you remember. So we have Lz phi is equal to mu phi. What is Lz? Minus I h cut del phi upon phi. So this is function, this is variable, is equal to mu phi. And this is only function of phi. I have just keep theta as a constant. So what will happen? This is only one variable. So you can write d phi upon phi, d phi upon phi is equal to minus mu upon I h cut del phi. So you can just go for integration and you can get ln phi is equal to I will take above. So this will be I mu upon h cut phi plus some constant. So I can write phi. This constant can be written in term of ln. So this will be a e to the power I mu phi upon h cut. I can get the value of a because it is normalized. So how you can get the value of a? So this will be phi star phi integration d phi 0 to 2 pi must be equal to 1. So you can easily get the value a is equal to 1 upon root pi. Are you comfortable up to this?
Yes, sir.
वेरी सिंपल, स्ट्रेट फॉरवर्ड, वन डायमेंशन. आप लोगों ने तो डिफरेंशियल इक्वेशन खूब किया है, isn't it? Now, so one unknown is mu. We have to also figure it out what is mu. So what will be the boundary condition? The boundary condition is phi plus 2 pi is equal to phi, isn't it? Because wave function must be single valued, and any if solution of any differential equation must be single valued. This is the very trivial thing. So wave function must be single valued. What is meaning of that? If you are rotating with a 2 pi angle and again 2 pi angle, you will get the same function. This is the boundary condition actually. And using this boundary condition, we can get the value of allowed value of mu. So what is this particular thing? So I can write 1 upon root 2 pi e to the power I mu upon h cut phi plus 2 pi must be equal to 1 upon root 2 pi e to the power I mu phi upon h cut. So what will be next step? So this thing is cancel out. So you have e to the power I mu 2 pi upon h cut must be equal to 1. So mu 2 pi h cut must be equal to 0, 2 pi, 4 pi, and this is plus minus. So mu is equal to 0 plus minus h cut plus minus 2 h cut, and you can write plus minus m h cut. Why I have taken plus and minus? Can anybody suggest me? Why I have taken plus and minus? Because you can move clockwise direction as well as anti-clockwise direction. Same as you can move the particle from plus h cut k or minus h cut k. So same reason, it is just a free particle in a circle, horizontal circle. So you can move clockwise, you have upward direction of angular momentum, anti-clockwise, you have downward direction of angular momentum. So why we have this kind of situation? So what will be the wave function? So the phi is equal to 1 upon root 2 pi e to the power I m phi. And what will be eigenvalue? The eigenvalue is equal to m h cut. This is the eigenvalue. What is value of m? M can be 0 plus minus 1 plus minus 2 and so on. So what you can get? You can get that z component of angular momentum is discrete. You cannot find all possible value of Lz. Either you have 0 h cut plus minus 1 h cut plus minus 2 h cut and so on. So this is all about the eigenvalue and the eigenfunction of Lz operator. So if you have any doubt, you can just ask me. Then I will go for L square operator. Are you getting everything? No response.
Yes, sir.
Okay, so let's go for Lz. So what is your L square operator? Again, L square operator is minus h cut square, and this will be 1 upon sine theta del upon del theta sine theta del upon del theta plus 1 upon sine square theta del square del phi square. Have you seen this type of operators? ये क्या है, कोई बता सकते हो?
Laplace equation.
लैपलास स्फेरिकल पोलर कोऑर्डिनेट में r वाले पार्ट को अगर कांस्टेंट कर दो तो थीटा एंड फाई विल बी द सेम थिंग, isn't it? So this is something like Laplace. So let us figure it out. So what we have L square and Lz is going to commute, and let's say psi theta and phi is the eigenfunction. So hence they are commuting. So eigenfunction of Lz will also eigenfunction of L square. So what I can say, I can write this all thing as psi theta phi as f theta e to the power im phi, because I know e to the power im phi is the eigenfunction of L square. And you know that theta and phi are independent. So yes, we can use this thing. So obviously this have to satisfy this equation, and I assume that lambda is eigenvalue. So what will happen? L square psi theta phi is equal to lambda psi theta phi. But we will put psi theta phi as f theta e to the power im phi, because we can easily use the variable separable, and we have enough evidence that we can do this variable separable because both are going to commute. So we can just put it here. So this partial differential will convert it into total differential minus h cut square. This is only partial in theta, so e to the power im phi will be treated as constant. So this is 1 upon sine theta d upon d theta sine theta d upon d theta f theta, and here d square upon d phi square will operate it to this. So this will be minus m square upon sine square theta f theta e to the power im phi must be equal to lambda f theta e to the power im phi. So what we will do, we will just equate the coefficient of e to the power im phi on both sides. We can just go and equate the coefficient of e to the power im phi on both sides. Once we will get it up to this, are you okay?
Yes, sir.
Okay. So this equation can be written as minus h cut square 1 upon sine theta d upon d theta sine theta df upon d theta minus m square sine theta f theta, and this minus sign I will take it that side and we will just commit in this side. So this will be lambda upon h cut square f theta is equal to 0. माइनस h कट स्क्वायर को उधर ले गए और इधर ले आए तो ये आपके पास आ गया, एंड वी हैव 1 upon sine theta d upon d theta sine theta df upon d theta plus lambda upon h cut square minus m square sine square theta f theta must be equal to 0. So this is my differential equation, and I have to solve this differential equation. So how we will solve it? we will put cos theta is equal to x, then sin theta minus sin theta d theta is equal to dx. So this can be treated as operator 1 upon sin theta d upon d theta is minus d upon dx. So we can use this particular trick. And when you are using this trick, I can put this thing as minus d upon dx. I can divide by sin theta here and I can take sin square theta. So I can write 1 minus x square and sin theta is here. Then you have d upon dx function f plus lambda upon h cut square minus m square 1 minus x square fx is equal to 0. Just look at here. Are you comfortable? क्या किया मैंने यहां पर जस्ट एक ट्रिक किया, साइन स्क्वायर थीटा और नीचे साइन थीटा कर दिया, तो d अपॉन डी साइन थीटा को dx लिख दिया, साइन स्क्वायर थीटा को 1 माइनस एक्स स्क्वायर, एंड दिस इज माइनस माइनस, सो दिस इज आल्सो माइनस, सो माइनस माइनस प्लस, सो इसको फाइनली लिखोगे, सो 1 माइनस एक्स स्क्वायर, दिस इज वेरी फेमस इक्वेशन, आपको याद आ जाएगा, डी स्क्वायर एफ अपॉन डी एक्स स्क्वायर, taking this thing common, and this will be minus 2x df upon dx plus lambda upon h cut square minus m square 1 minus x square fx is equal to 0. ऐसा डिफरेंशियल इक्वेशन देखा है?
Legendary polynomial.
Very good. So this is what? Legendary polynomials. The solution of this differential equation is will be Legendre polynomial if there is some condition. So what is this condition? The solution of this differential equation will be equivalent to Legendre polynomial if, and why I am going to some polynomial, because I have to work into Hilbert space and I know that polynomials will be very suitable function for the Hilbert space. So whenever you will solve the differential equation, you will always search the solution must be converges to some Hilbert space function. So polynomial is the very good guy. So why this thing we have just, and look at this mathematics will work. This intuition and this mathematics will work, and it will give you the exact relationship. What you are going to observe into the lab. This is very interesting. So why mathematics is said to be language of God. No other language is the language of God, only mathematics, because it works with the observation. So let's go for this. So what is the condition? That condition is lambda upon h cut square. It's something like L into L plus 1. What is L? And L plus 1 is two consecutive number. If lambda upon h cut square will be something like L and L plus 1, two consecutive number, and that is positive number, as well as the value of m will be between minus L to plus L, the solution of this differential equation, and I will prove it also, and the solution of this differential equation, fx is basically Legendre polynomial. And here I have put lambda is equal to L into L plus 1 h cut square, and I can put L ki value 0, 1, 2 and so on. And this is nothing but the solution of Legendre polynomial, and fx is nothing but you can put f theta, f cos theta basically, and this cos theta is all about PL cos theta, and you know what is the Legendre polynomial. And here the actual wave function is all about psi theta phi, and this will be nothing but PL cos theta e to the power im phi, and this is known as spherical harmonics. This is known as spherical harmonics. And this thing is identified as kit L and M. So whatever be the calculation we have done, it will nothing to do with your calculation. Nothing to do with your calculation. But we are doing quantum mechanics, so we have to do this. But for the application point of view, only this L and M are important. I can start from only from L and M also, but that will be half-hearted approach. So you can see this is your YLM and this is your LM operator. So if you have any doubt, then you can ask me. Otherwise, I will conclude all this result what we have get here. So what we have a very simple kit. And don't worry, I will prove that M will be between minus L to plus L. I will prove it, but different method. Because if I will prove with the differential equation method, it will be very boring. So what we have L square YLM theta phi. I will give you what is YLM. That will be L into L plus 1 h cut square YLM theta phi. And what will be LZ? YLM theta phi is equal to M h cut YLM theta phi. And what will be the orthonormal relation? The orthonormal relation is 0 to 2 pi, 0 to pi, y L dash M dash star theta phi, y Lm theta phi. And obviously, what will be the variable here? Please tell me what is the variable here? Anybody? What is the variable here?
Phi.
Hmm?
A
Only
theta.
phi.
D theta D phi.
D theta D phi, sir.
कभी ऐसा मिला है तुम्हें? That will be sin theta d phi.
Yes.
This will be the variable. Solid angle. We are just talking about the solid angle, isn't it? This will be equivalent to delta L L dash, delta M M dash. इसी पूरे चीज को हम ऐसे भी लिख सकते हैं. L square L and M is equal to L into L plus 1 h cut square L and M. LZ L and M will be M h cut L and M, and this whole thing can be written as L dash M dash L M. That will be delta L L dash delta M M dash. So बताओ प्रॉब्लम करने में कौन सा काम आएगा मच बेटर ढंग से? ऑब्वियसली उसमें करेंगे. इतना कौन लिखता है बार बार इंटीग्रेशन और बार बार ये सारी चीजें. Okay, so you have this kind of, so this is all about your L square and LZ, but your obvious question is how you will get Lx and Ly. You want to know how Lx and Ly will behave. So for that, we will just go for ladder operator. So let's go for ladder operator. Up to this, if you have any doubt, you can just ask me. And please, for the examination purpose, whatever I have done, that is not so important. What is important that how you are going to apply this thing. So just focus on this, and next class is most important for your examination purpose. But we are doing physics, so I have to do this thing. It is my responsibility. Okay. So should I go ahead?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So let's go for a ladder operator. So I have L plus operator, and this operator is Lx plus I Ly. L minus operator is Lx minus Ly. So obviously you can again have L square and L plus will be 0. You can easily find. And you can also find L square and L minus is also 0. You have also find L square and Lz is 0. Let us try to calculate what will happen Lz and L plus. So L plus is nothing. So this will be Lz Lx plus I Ly. So you have Lz L plus, sorry, Lz Lx plus you have Lz Ly into I. What is Lz Lx?
Iota H cut L
Very good. Iota H cut Ly.
L
है ना? Good. Now, what is Lz Ly?
minus
Minus IH cut.
Minus IH cut Lx. So minus minus plus. So you have, isn't it? So minus IH cut I. So what we have? We have H cut. This is Lx. Okay. So H cut Lx plus I Ly. What is this thing? This thing is H cut L plus. So you have one very good interesting concept. Lz L plus is H cut L plus. This will H cut L plus. Similarly, you can figure it out that Lz L minus is minus H cut L minus. You can easily figure it out same way. So I am just giving you homework that you can just do with yourself. थोड़ा तो अपने से भी करना चाहिए. Now you can see L square is commuting with L plus, L square is commuting with L minus, L square is commuting with Lz, but it is not necessary that Lz is also commuting with L plus and L minus. This is very interesting. You know this property, A can commute with B, B can commute with C, but it is not necessary that A and C will commute. So this is the one of the best example. And what will we use of this particular thing? These two things, we will discuss it in tomorrow morning. Okay. So I think we must stop here. So we will discuss all this thing in tomorrow morning. So first half, so you have 2 classes in morning, isn't it?
Yes, sir.
So we have 2 classes in the morning. So first part, we will just go for algebra. It will take hardly 15 minutes. And then we will go for different types of problem. In rest of the class, we will just go complete tomorrow this angular momentum algebra. And again, the same thing will come into spin. So next 4 classes, we will just cover this all angular momentum thing, space quantization in different way. So if you have any doubt, then you can ask me. So should I leave?
Yes, sir. Thank you.
Okay, thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.